Now this is question number 5. It says a dead body was found within a closed room of a house where the temperature was constant, 70 degrees Fahrenheit. Immediately I know that that is going to be my room temperature, 70 degrees Fahrenheit. I'm going to write that down. So my Tm is going to be 70 degrees Fahrenheit. It says at the time of discovery, the core temperature of the body was determined to be 85 degrees Fahrenheit. Now note, it says at the time of discovery. We do not know the time of discovery. But we're told that at the time of discovery, the core temperature of the body was determined to be 85 degrees Fahrenheit. Now, since we do not know the time of discovery, I'm going to represent my time of discovery with X. So I'm going to say let X represent the time of discovery. So if X is the time of discovery, we are told that T of X equals 85 degrees. 85 degrees Fahrenheit. Now, 1 hour later, a second measurement showed that the core temperature was 80 degrees Fahrenheit. Now, the 1 hour later is with reference to the time of discovery. So that implies that at T of X plus 1, the new temperature of the body was found to be 80 degrees Fahrenheit. Now, we're told that we're given an assumption that assuming that the time of death corresponds to T equals 0, and that the core temperature at that time was 98.6 degrees Fahrenheit. So that should tell you that that is going to be your initial condition. That is what our statement simply implies, is that at time T equals 0, our temperature is 98.6 degrees Fahrenheit. 0.6 degrees Fahrenheit. Now we are told to determine how many hours elapsed before the body was found. The body was found when? The body was found at the time of discovery. So we are told to find X. This is just what we are told to find. Now, like I used to say, whenever you want to solve a question, you first observe what kind of process is going on here. Now, the processes that are going on here involves the loss of temperature and the gain of temperature. One is losing, one is losing, and one is gaining, stuff like that. So the first thing you need to think, or you want to think about, is what differential equation actually models the behavior of the processes involved in this problem. What is it? Newton's law? It's Newton's law. So you see that the temperature of the body starts from 98 and begins to decrease. So we're using Newton's law of cooling. So that's what we're going to be using here. So the model is Newton's law of cooling. So now, having known all this, let's now begin solving the problem proper. Yeah. So let's push this up. Now, according to Newton's law of cooling, we have that the rate of change of temperature with time is proportional to the change or the difference in the temperature of the body with the environment, Tm. And from here we have our Tm to be 70, so this is going to be K into T minus 70. So this is what we have as our K. So now let us solve this differential equation first. So what we have the T equals K into T minus 70. So to solve this, we use the separable method like we've been doing. So you have the T So we have the t divided by t minus 70 equals k dt, and then we integrate both sides. So bringing that here, we have the lane of t minus 70 equals kt plus c. So this is going to give us t minus 70 equals b e to the power k e to the power kt, and then finally we have t to be equal to 70 plus b e to the power k b to the power kt. So now this is what we have, and then we are told that at time t equals 0, the temperature is 98.6 degrees Fahrenheit. So that is the temperature when the time is 0. So we're going to implement that here. So we now have is 98.6 equals 70 plus b e to the power 0, that's 1. So that implies that b equals 98.6 minus 70, and then when you subtract that, you have your b to be equal to 28.c. So now we now have our b, so we now have our new t. We have our t, which is this. So we have our t to be equal to 70 plus 28.6 to the power k to the power kt. Now the next thing is, we need to use these two conditions that we're given also. Let me call this condition 1 and call this condition 2. So the first condition says when t is x, our big T is 85. So when t is x, big T is 85, which I'm going to write as this. So we have 85 equals 70 plus 28.6 to the power k times. Now when t is small x, and then the next condition says that when small t is x plus 1, big T is 80. So we're going to that now. It says 80 corresponds to 70 plus 28.6 k into x plus 1. So that's going to be kx plus 1, kx plus k. So now from here we have 85 minus 70, so that's going to give us 28. So this implies that 28.6 to the power kx equals 85 minus 70 is 15, and then this is going to give us 28.6. So this is laws of indices, so we can just write this as 28.6 to the power kx times 28.6 to the power k, now equals 80 minus 70, which is going to be 10, which is 10 anyway, which is 10. So now how then do we solve this problem? Oh, I think we must have made some little error here. So we have b e to the power kt. So this is going to be e. There should be an e here. Sorry for that. So there should be an e here. There should be an e here. Oh. So we need to clean this area here. So this is 70 plus 28.6 e to the power kt. So that's e to the power k, e to the power kt. So this is 28.6 e, so there should be an e here also, e to the power kx and then there should be an E here too. So that's 28.6 e to the power kx, and this is 28.6 into e to the power kx times e to the power k. So this is what we have. So from here we have 28.6 e to the power kx equals 15. And then this gives us, this is the same thing as 28.6 e to the power kx, and then e to the power k equals 10. So since we have 28.6 e to the power kx equals 15 here, so instead of writing 28.6 e to the power kx, I'm going to rewrite it as 15. So you're writing that what we have is 15 e to the power k equals 10. So to find e to the power k, so that'll be 10 divided by 15, and that's going to give us approximately 0.667. 0.667. So to find k, we take the natural logarithm of both sides. So k equals the natural logarithm of 0.667, and that is going to give us negative 0.4405. So that is what we have for our k. Now the next thing is, how then do we find, now since we have our value for k, so we want to find x. So from here we can find x. So we have, so I'm going to be using, let me call this 2.1. So using 2.1, we have 28.6 e to the power k. Now, so our k is negative 0.405x equals 15. So to find x, I need to divide both sides by 15. I mean both sides by 28.6. So you have e to the power negative 0.405x equals 15 divided by 28.6, and that's going to give us 0.5244. 15 divided by 28.6, which is 0.5244. So to find x, we take the natural logarithm of both sides like we've been doing. So you have negative 0.405x equals the natural logarithm of 0.5244. So therefore x equals the natural logarithm of 0.5244 divided by negative 0.405. So this is what we get for that part. And then when you simplify that, what we're going to have is 1.593. 1.593 hours. So x equals 1.593 hours. So that is exactly what the problem actually told us to find. It says a dead body was found within this. Determine how many hours elapsed before the body was found. So this is